Laniakea, our cosmic watershed. Here, S where the map stops being a dot hunt and turns into a living river. Researchers took those noisy arrows, the peculiar velocities that wouldn't line up, and asked a different question. If you follow each arrow downhill, where does it ultimately end? Not tomorrow, not next million years, but asymptotically, when the local jostling fades and only the broad slope matters. Trace enough of those paths, and a boundary appears not drawn by where galaxies sit, but by where they're headed. That boundary got a name, Laniakea, immense heaven. It's our basin of attraction, identified through flow reconstruction, with a local sink near the Norma, Centaurus region. The stakes landed right away. We thought our home was the local group, a small neighborhood carved by the gravity between the Milky Way and Andromeda, and a scattering of dwarfs. Then maybe we were part of the Virgo supercluster, anchored by the Virgo cluster tugging nearby space. The flow map said both were too small to describe our true address. Our real home was a basin that gathers tens of thousands of galaxies into a shared fate. Belonging here isn't about membership in a club. It's about which way your velocity arrow ultimately points. Action-wise, the team built a dynamical atlas. Start with distances and peculiar velocities from multiple methods so no single yardstick dominates. Smooth with techniques that respect uncertainty, Wiener filtering, forward modeling, and reconstruct both the density field shaping space and the velocity field that rides over it. Then you do something simple and radical. You let virtual test particles flow along that field from their starting points. Where they converge, you declare a sink. Where they diverge, you declare a ridge. Connect the ridges and you sketch borders. Laniakea emerges as the catchment area of a major sink near the Norma and Centaurus region, the same direction where the arrows had been nagging us for years. The impact is an identity shift you can feel. The Milky Way stops being a lone ship with a few escorts and becomes one drop in a sweeping river. The Great Attractor, recast, is the sink of this basin, the place the lines head toward within the resolution of the map. But sink doesn't mean a single cluster you can circle with a pen. It's a dynamical feature spread across a region where flows decelerate and aim together. A gravitational low created by the collective mass of clusters, filaments, and the dark matter skeleton beneath them. Now remember, basins aren't just bowls, they have ridgelines. In this map, ridges are where neighboring rivers part ways. You can watch flow lines on one side peel toward Virgo, a modest shepherd guiding traffic in our near field, while lines on the other side trend past Virgo and bend toward the deeper south. Those ridges aren't physical walls. They're dynamical divides. A galaxy nudged across one by a merger or a long-term drift can end up in a different fate channel. But for most of the traffic, the lines hold. The watershed is real. Human moment, someone in the room said, let's name it like explorers. Laniakea stuck because it framed the scope without pretending to completion. It said, this is big, humbling, and navigable only by reading the stars. On release day, phones lit up. People didn't argue about whether the Virgo cluster exists. They argued about the boundary drawn by motion. That was the point. The map wasn't telling us where matter piles highest. It was telling us where history is dragging us. Complication, plenty. Flow reconstructions depend on priors. Distance errors smear streamlines. The zone of avoidance still bites, so parts of the basin's edge are sketched from indirect hints. Change the smoothing scale and the exact border wiggles. But across reasonable choices, the structure persists. You get a coherent catchment feeding a sink near Norma, a secondary guide near Virgo, and a shared lean that refuses to die when you swap catalogs. Here's the twist the arrows had been whispering since the last section. When you follow the flows inside Laniakea, many don't stop at the sink. They bend. Downstream, the grade steepens again. The velocity field keeps tilting toward a weight farther out. In hiking terms, the bowl pours into a deeper valley. In traffic terms, the city center funnels onto a freeway that heads to a bigger metropolis you haven't reached yet. The Great Attractor becomes a junction. The river doesn't end there. It leans toward the Shapley Concentration. Impact again, but downstream. This reframes risk and reach. If our basin is leaning toward a heavier weight, then today's convergence is part of tomorrow's migration. We can belong to Laniakea and still be passengers on a longer route that arcs past it. That tension matters when we talk about horizons and what expansion allows us to ever actually meet. It also matters for meaning. If your home is defined by motion, then your identity includes where you're going, not just where you stand. Microstory, late-night fluorescent buzz, a plot with streamlines overlaid on a skeletal web. A thin ribbon of flow peels off the Virgo-guided branch and threads the blind spot. Someone taps the screen. This line is us. Silence, then a laugh that sounds like plea and pride. That arrow doesn't know our calendars or languages. It only knows the slope. So what's the takeaway you carry? Laniakea is our watershed, drawn not by brightness but by destiny of motion. The Great Attractor is its local sink, the place our lines collect before they lean again. Virgo is a nearby traffic officer, not the final courthouse. And the boundary itself is alive, ridgelines where decision happens, where tiny nudges decide which future you flow into. Because downstream, something heavier was warping the
Shapley,
entire basin downstream. While we were celebrating the map that finally gave Laniakea a shape, the arrows were already filing an appeal. They leaned past the sink. Beyond the hidden crossroads near Norma and Centaurus, the grade kept dropping. If the Great Attractor was the city center, the freeway out of town pointed to a skyline we hadn't really faced. Downstream sat a domain with its own gravity, louder and farther. The Shapley Concentration, an exceptionally rich supercluster complex whose mass explains much of our downstream lean. Here's the stakes check in plain terms. If the deeper slope lies beyond our basin, then our motion isn't just local housekeeping. It's regional weather. That matters for how we measure distances, how we calibrate supernovae, and how we tell the story of where we live. Get the deeper pull wrong, and you bias every yardstick tied to redshift. You misread how fast structures assemble. You assign blame to the Great Attractor for traffic it's only directing, not causing. In other words, you mistake a junction for a destination. Action moved quickly once the suspicion sharpened. Redshift surveys that looked past the zone of avoidance began to reveal an enormous overdensity farther along our velocity vector, hundreds of millions of light-years out. Catalogs of rich clusters, able catalogs and their refinements, flagged an unusual crowding of massive clusters packed into a swath of sky in the direction of the constellations of Centaurus and Horologium. X-ray observatories saw the telltale glow of hot intracluster gas, the plasma halos that make giants obvious even when their galaxies blur. Stacking these signals, a picture emerged: the Shapley Supercluster, a concentration so heavy it warps flow fields over vast scales. Meanwhile, the velocity reconstructions kept nudging the same way. Trace streamlines from our neighborhood through the Great Attractor region, and many bend toward Shapley like a river pulled by a deeper canyon downstream. Bulk flows that seemed to converge near Norma did not terminate there. They reoriented. Kinematic signatures, far-side redshifts and near-side blueshifts across cluster complexes, showed infall patterns feeding not just the local sink, but a larger basin slope beyond it. What started as a nickname, Great Attractor, got demoted to Waystation by the math. Impact hit hard in the community. The reframing was simple: the Great Attractor channels, Shapley dominates. Mass estimates for Shapley carry big error bars, selection effects, incomplete sky coverage, messy cluster membership. But every method kept it big. Tens to hundreds of rich clusters nested in filaments, hot gas lighting the scaffolding, gravitational footprints stamped across flows we could measure from home. Once you fold Shapley into models, the amplitude and direction of our peculiar velocity look less mysterious. The deep valley explains the lean, especially when balanced against the opposite underdensity. Human moment. A senior astronomer put down a marker and said, half relief, half dread, "We've been blaming the wrong mountain." The room laughed quiet. Solving a mystery by finding a bigger one is classic astronomy. You spend years arguing over a local sink, then discover the basin slope owes rent to a heavier landlord farther out. Now, not every arrow bows to Shapley. The local web is tangled. Virgo still shepherds near-field motion. Other concentrations, Hydra, Perseus Pisces, the South Pole Wall, tug on their neighborhoods. The cosmic web is a compromise of poles. But when you average over the noise and let the data speak with weights that match their uncertainties, a coherent story survives. The direction flagged by the cosmic microwave background dipole, the peculiar velocity catalogs, and the reconstructed velocity fields points past the Great Attractor toward Shapley. Complications keep us honest. Selection biases haunt redshift surveys. Brighter clusters get cataloged first, skewing perceived structure. The zone of avoidance still erases lines right where we love continuity. Distance indicators carry intrinsic scatter. Malmquist bias can inflate inferred flows in undersampled regions. And X-ray luminosity is a messy proxy for mass. Cluster physics, cool cores, mergers, jitter the relation. So mass estimates for Shapley arrive with caution labels. Yet the convergence of multiple, imperfect probes is exactly what gives confidence. Different messes, same conclusion. There's a subtle intuition flip hidden here. Calling something an attractor makes us think of a point that swallows. But Shapley, like the Great Attractor, is not a drain plug. It's a sprawling depression in the gravitational landscape, a complex of valleys nested inside a broader low. Flows don't drop into a singular place. They decelerate into regions where the field lines converge, then curve again if the larger scale slope keeps falling. That's what the reconstructions imply. Laniakea pours toward a local sink, then tips down a ramp that aims at the Shapley domain. Microstory. A researcher scrolling through a three-dimensional render of the density field paused, rotated the view, and watched a filament, ours, thread the blind spot, brush the Norma hub, then arc toward a knot of clusters glowing in X-ray overlays. There, she said, not triumphantly, but like naming a distant relative you've only seen in grainy photos. That's where the floor goes. Impact, personally, is an identity shift twice removed. First, we traded the local group for Laniakea. Now we accept that Laniakea itself leans towards Shapley's deeper stage. Belonging becomes layered. Local tides here, basin membership there, downstream allegiance to a heavier weight beyond. It is less a mailing address than a travel itinerary written in gravity. And yet one more perspective tug waits at the edge of the map. If Shapley sets the deeper slope, why does our motion fit even better when we include something else? A push opposite Shapley's pull. The flow looks symmetric only when we admit a second actor, not a mass but an emptiness. The next bend in the river isn't just about what's ahead. It's also about the hill behind, the Dipole Repeller. The Dipole Repeller, a push from the void. So if Shapley is the deeper valley ahead, why does the model still feel off unless we factor in something behind us? Here, S where the map flips intuition. Gravity only attracts, but motion through a lumpy universe creates patterns that act like pushes. In the reconstructed velocity field, there's a broad, underdense region roughly opposite Shapley that behaves like a hill. Streams flow away from it. In kinematic terms, it repels. People started calling it the Dipole Repeller, a kinematic repeller inferred from velocity field divergence, not a new kind of force. Stakes first. If our 600 km/s drift is shaped by both a pull toward mass and a push away from emptiness, then ignoring the void breaks the symmetry. Our distance measures skew. Our calibrations wobble. We misread the basin's boundaries and overcredit the Great Attractor for motion the void is helping to drive. The consequence isn't abstract. Every galaxy in our catalog sits in a field sculpted by both valleys and hills. Get either side wrong, and you misplace where the river should run. Action came from the same engine that revealed Laniakea, velocity reconstructions that translate noisy, peculiar velocities into smooth density and flow fields. When researchers inverted the flow to map out not just where mass collects, but where it's missing, a coherent underdensity bloomed opposite the pole. In that region, streamlines splay outward. Test particles seated inside are carried away along multiple filaments. It's not anti-gravity. It's gravity doing exactly what it should when there's less matter in one place than around it. Think of a gentle rise shedding rain. Meanwhile, something else was happening across town in the data. When the model included both Shapley's pull and the void's effective push, the predicted direction and amplitude of our peculiar velocity lined up better with the cosmic microwave background dipole. The residuals shrank. The fit improved. The "but they're still missing momentum" argument lost steam. In other words, the void mattered as much to our trajectory as the famous concentrations of clusters we love to put on posters. Impact hit in the way we talk about flows. The community started leaning into the Valley Hill language. Attractors are valleys where streamlines converge. Repellers are hills where they diverge. The math is still gravity. The narrative gets clearer. You can trace our arrow as a compromise between an escape from the underdensity and an approach toward the overdensity. The words push and pull here are metaphors for the shape of the field, not new forces, but they help you feel the current. Complications kept everyone cautious. Voids are hard to sample. By definition, there are fewer galaxies to trace. Selection effects bite harder in emptiness. A shallow survey might miss the few faint galaxies that define the boundary, making the whole look larger or deeper than it is. Reconstructions depend on smoothing scales, change the filter, and the apparent crest of the hill shifts. Distance errors propagate badly through inversions. Malmquist bias can make outflows look faster. And yet, across reasonable choices, a large underdensity in the opposite hemisphere kept reappearing, and the kinematic signature, divergence, persisted. Human moment. In a cramped office, a postdoc slid 2 plots across a desk. One had only attractors. The arrows leaned, but the fit to the microwave background wasn't pretty. The second plot added the void. The main streamlines sharpened, the angle tightened, the numbers breathed a little easier. "It's not a monster," she said, tapping the blank patch. "It's a missing." The room nodded, the kind you do when absence suddenly feels active. Here's the intuition flip that rescues sanity. We're trained to think force when we hear repeller, but the universe doesn't need new forces to make outflows from voids. With less matter to pull inward, surrounding regions dominate and motion peels away. Kinematically, that looks like a push. Dynamically, it's a lack of pull. Frame it as water again. A broad dome shed streams down its sides, even though no source is shoving uphill. The shape alone dictates the flow. Meanwhile, add a tease. When you include the dipole repeller, the basin edges of Laniakea make more sense. Ridges become cleaner where flows split between Virgo's shepherding and the longer arc toward Shapley. The local web stops looking arbitrary and starts looking like the natural compromise between fleeing a hill and sliding into a valley. And that clarity feeds straight into the next dilemma we can't avoid. The river we're following is flowing through a landscape that itself sits inside an expanding ocean, accelerated by dark energy. Impact, personally, is acceptance. Our motion isn't a single heroic arrow spearing a target. It's a negotiated path between emptiness and fullness. That's not just poetry. It's why the map feels stable once you balance both sides. Get this balance right, and the story of the Great Attractor and Shapley settles into place. A valley ahead, a hill behind, a current that makes sense of the bruise on the oldest light. Now the current had both banks, the valley ahead and the hill behind. The map isn't the territory, uncertainties and blind spots. Here's where humility earns its seat. We've drawn a river, named a watershed, pointed to a valley and a hill, but the map we're holding is stitched from partial glimpses, noisy yardsticks, and choices that leave fingerprints. The zone of avoidance still crosses our chart like duct tape. Selection effects lean our samples. Biases creep in when we only see the brightest or the nearest. The story holds, but the edges blur. Stakes first. If we misread the fog, we don't just get pretty borders wrong. We tilt the entire velocity field. Distances bend, masses shift, error bars hide overconfidence. A small skew in one catalog propagates like a rumor into reconstructions that dozens of papers build on. People hang careers on which priors they choose, which distances they trust, which smoothing scale calms the noise without flattening the truth.